Hi, and welcome to Code Corner. This is a video series we like to do at Mayfield Renewables where we talk about codes and standards as they relate to the solar and solar plus storage industries. Today we're going to talk about NFPA 70B, so the standard for electrical system maintenance, and specifically we're going to talk about infrared thermography as it relates to our PV systems. So in 2023, Chapter 30 was added, so there's photovoltaic system specific requirements that are now listed in NFPA 70B. And thermography is not anything new that's new to 70B. The PV systems, that is new, but there are some changes when it comes to the 2023 version and infrared thermography. So we'll kind of touch on those as well and how they apply. It's actually going to apply across all electrical systems, so PV systems will be included in it. So there's kind of a brand new stuff on both fronts for infrared thermography. So first off, before we get too far into it, table 30.4.5 in 70B is where you're going to find these call outs to the tests for our PV systems, and what you'll notice there is really every single one of those in the notes section, in the notes column, every single one of those tasks, the electrical terminations, grounding, bonding, PV strings, modules, module interconnections, all of those testing areas call out thermography as one potential way of doing the test. So, thermography is a pretty big and broad, I would say, application, so we can use it to find or to help highlight maybe multiple issues, and so this is something that highly recommend that you get more education on. Thermography is definitely something that you need to understand when you're going and working with the tool, especially around PV systems. We have some images that we'll show you, but you want to make sure that you are using the tools properly and being able to understand what those results are telling you. So again, 70B puts it as an option, and so it's one that I highly recommend utilizing. So chapter 7, I mentioned before that infrared thermography is not new to 70B, and so you see 7.4 talks about infrared thermography specifically and talks about what you're trying to do. So you're trying to verify a temperature difference, the delta T, of certain areas of your electrical installations. So you want to look at similar electrical components under similar loading. So you want to, in the context of our PV systems, if you have an inverter or you have a combiner box, you're going to be looking at those electrical terminations, and you want them to be similarly loaded. So you don't want some of the array to be off and some of it to be on. You want it to be having it be loaded so that you can see actually what's happening when the current's flowing. And then your comparison between the electrical components and the ambient air temperatures. So trying to differentiate and understanding, and especially when it comes to our PV systems, we have these components out exposed to pretty extreme temperatures sometimes, and so understanding what's happening, why is that fuse or that circuit breaker as hot as it is, and then being able to understand, is that just a function of its normal operation because it's in an environment that's greater than 100 degrees Fahrenheit, out exposed to the sun inside of a hot green box. All of those things would come into play. So making sure that you're understanding those as part of that process of getting educated and understanding how to run the tests and what the results are telling you. But 7.4 continues on and just kind of talks about, and so some of the big things that are towards the 7.4.4, performed under normal circuit loading. So you want the array to be operating. It does give you this 40% nominal circuit loading shall be permitted, and then noting or documenting the results. So 7.4 kind of goes through those, and something that is new in 2023 for 70B is this in chapter 9.2 and 9.3. So 9.2 talks about the frequency of maintenance, and the frequency of maintenance, it gives you a table, 9.2.2, and it shows you a whole table of all the different components or all the different tests and how frequent you should be doing them. The very top of it talks about electrical components and thermography, and so the new thing in 2023 is it's saying that you should be doing thermography of your electrical system components at intervals of no greater than 12 months. So annually, at a maximum, you should be going out and taking these measurements. The table does include some equipment condition assessments, and so that shows up in 9.3. It tells you exactly what those assessments, what those conditions are. It goes from the basically brand new equipment in the condition 1 to the systems that are aging, they're starting to see some wear and tear, and 2, and then number 3 being either you've missed consecutive tests, or the last test you did showed that there was some severe maintenance that needed to be happening. So kind of breaks it down into these 3 conditions. But even condition 1, even for brand new equipment or equipment that's operating perfectly, it's saying that you're going to check it at least every 12 months. And so this just needs to get put in that toolkit in terms of what, as an O&M operator, when you're going out and checking the systems, this is just something you're going to be doing on an annual basis, pulling out the infrared gun and be able to take a look at what those components are, how they're acting under load, and making sure that they are operating as you're expecting. So some of the things I just want to kind of point out, you've probably seen plenty of these images out there, and so here's a couple images from field site visits, and so you can see there, looking at that, the one on the left, we have a connector, so a quick connect for our PV modules, and you can see that it's operating quite hot. And then again, the key here is we're comparing it to what the ambient temperature is. What are the other components in that system that are similarly loaded? Are they running that hot? Are they not? So again, a picture in time, or a still like this, that's pretty dramatic, seeing that temperature there. And I think that part of this was to illustrate that there was an issue here, but being able to compare that to similar systems is really important. And then there on the right, the reason, one of the things I wanted to show, using them on PV modules, and again, going through and making sure that you're properly trained and educated on those, because when you're using infrared cameras on things like modules, you're going to get some reflection. You're going to have that glass is going to react differently. You can get, false hotspots or things like that. So making sure that you're approaching it from the right angle, at the right distance, that you have the emistivity set properly on your camera. So all of these things are things you have to be aware of. But when they're being done properly, you may find things like these hotspots on modules. And so in this case, we see some modules there that look like they have some hotspots on them. Compare that with the other cells within this within the module themselves, can help give some clues on what's going on or what some problems are. Maybe there's an issue with a diode inside the junction box, in that one super hot cell or something like that. So all those things are items that you're looking for and wanting to discover, but again, making sure that you're using the tool properly and understanding what's going on. And then in this last set of images, we have hopefully some of this would be apparent from a just a visual inspection. There on the far left, we have some conductors that were not properly installed in those fuse holders. We have issues there. Obviously, that was a post-event picture there where we had some sort of fire, something going on inside that inverter wiring compartment. And so all of those things, again, annual maintenance using infrared cameras should be able to hopefully catch those early, and then be able to mitigate any potential problems that you have. So a lot of this was put together as part of the electrical testing standards guide that we at Mayfield are working with Megger on. And if this is of interest to you, I highly recommend that you go take a look at the guide as it's available. And we get into things like ground fault testing, electrical continuity testing, insulation resistance testing, and how those tests are applicable to our PV systems, how they are governed under IEC rules, under NFPA 70B rules. And so just trying to put all that stuff into practice for our PV systems and the arrays that you're out there maintaining. So highly recommend that you go take a look at it. If you have comments, input, or anything like that, we'd love to hear from you. This is an ongoing project with Megger, so we'd love to make sure that we're integrating the voices of the industry to make sure that we're getting the best information out there as possible. And then if you are interested in additional courses from Mayfield Renewables, take a look at our website. We do have some pre-recorded on-demand classes available, and they're NABCEP accredited, so you can get NABCEP continuing ed credits for those. But we also do in-person and live trainings for whole teams, and so if that's something that you would like to see or would like to understand how we might be able to help your team specifically on a number of topics, feel free to reach out, and love to talk to you about that as well. So thanks for your time. If you have questions on this or other Code Corners, always love to hear from you. If there's topics that you want to see us cover on other Code Corners, giving that input is always welcome as well. So I appreciate you taking the time to watch this, and hopefully we'll see you soon.